The cross product. You guys remember this from Algebra 2 and 3x3 matrix. Basically what we're doing is finding the determinant, basically. So you should recognize what it is we're doing. It's not exactly like a 3x3, but I'll point out all the things. And even if you don't remember it, I'm just going to show you what to do. I'm going to show you 3 different ways. Each way gets easier and easier. You decide how you want to do it. So given a a vector, a sub 1, a sub 2, and a sub 3, and a vector b, b sub 1, b sub 2, and b sub 3. The cross product gives you a vector. Now, you can put this in your reference sheet if you want, but my guess is you want to wait until you see all the things that I'm going to show you. This is the first way of doing it. The first way, which I don't think about myself doing, I actually write it down a little bit differently. This is a sub 2 times b sub 3 minus a sub 3 times b sub 2. This is what it shows you in the book. That's the first position of the vector. The second position is a sub 3 b sub 1 minus a sub 1 b sub 3. And some people like to do it like this, so I don't know who that is. Whatever. It's a comma. And then the third position is a sub 1 b sub 2 minus a sub 2 b sub 1. You can memorize that, or you can look at it this way. This will be number 4. Can you see it? This is what's in your book. I would advise you not to try to memorize that. That's just crazy. Okay? Vector A is 0, negative 4, 1. Vector B is 1, 1, negative 2. Alright, so what we're going to do is we're going to set up a 3x3 matrix. It's really only going to be a 2x3, but we have I, J, and K. Those letters are the first row of your matrix. The second row is A, the third row is B. And we look at it like this. This should start to look familiar with what you're going to do. I'm going to put these 2 columns right here. It's starting to look familiar at all?
Matrices.
Matrices, but it should look familiar here in just a second. So to get the I position, the first position, is that the first position? I, J, and K. We take this diagonal, the I diagonal, negative 4 times negative 2, minus the upward diagonal, the upward I diagonal, 1 times 1. Does that look familiar? And then the J position is 1 times 1 minus the J position going upwards, negative 2 times 0. The next example, I'm going to clean this all up and give you the real shortcut. It's actually doing this exact same thing, it just looks better. Okay? And all of these entries are these entries here, these positions. Okay, so we have K next. 0 times 1 minus the K diagonal going up is this right here. 1 times negative 1. You could have put the K column here and done it, but there's no reason to do that. And then do the calculations. Negative 8 minus 1 is negative 9. Or excuse me, positive 8 minus 1 is 7. 1 minus 0 is 1. And 0 minus a negative 4 is positive 4. So you can write it like the vector, or you can write it in the expression form 7i plus j plus 4k.
Is there application stuff to all this that we're doing?
Oh yeah, there's lots of application with matrices and determinants, which we get into chapter 10. Chapter 10 is all matrices. And in chapter 10, finding the determinant, we're not going to let you use your calculators. The honor students get to use their calculators. But when you go to college, your linear algebra teacher is not going to let you use your calculator to do that. You have to show that you can do it by hand. It's not difficult. I mean, this is all you're doing. You can do this by hand. But there's a way to do it on your calculators. So on the test, if you figured out how to use your calculator to find determinants, I'll let you do that. But for your homework and your quizzes, you have to show me that you can do this by hand. But it's not difficult. This isn't, a lot of trigonometry. This is just multiplication and subtraction. All right, so there's one way to do it. Now let's do number 8, because the next one I want to do. Yeah. So I'm going to go ahead and set this up in the matrix form already. 3, -1, 0, and 0, -3, and 1. Notice I didn't put the I, J, and K on there. Again, you can set it up like this, okay? Or you can do this, or you can do what I'm going to do here. Okay, whichever way is okay with you. This is how I would do it for this. I'm just going to add the first column here. I'm just going to show you what we've already done. We're not doing anything different than what we did right here. We're not putting all this other stuff on here. I want you to see something. The I is in the second and third column here. And the I going the other way is in the second and third column. So it is the 2 by 2 matrix determinant that you're finding. This is I. So find your 2 by 2 determinant right there. Or I should say inverse. Crazy. Or determinant. Whatever it is. Okay. -1 times 1 minus -3 times 0. So that's the first one. Now I want you to notice over here. We ready? J covers the third column and the extra column. And the other J starts with the third column and the extra column. So the second, or the J position, deals with the last 2 columns here. So we have 0 times 0 minus 1 times 3. You don't have to draw the boxes, I'm just pointing it out to you. And guess where K is? Look at K. K covers 0, 1, which is really the first and the second column here. We added those right here, didn't we? And the upwards K is on the first and second column. So really, your K position is the first 2 by 2. 3 times -3 minus 0 times 1. So you could just add the extra column, do the middle 2 by 2, the last 2 by 2, and then the first 2 by 2. Got it?
Did you come up with that yourself?
Yes.
It's pretty baller.
It's just this. This just looks cleaner. You don't have to take up a lot of space. What? No, you do this, you do this. If you need to do a couple where you have the I, J, and K above it to help make sure you're doing it in the right order and you have to follow that, that's fine. Eventually get to the point where you should just kind of notice what it is that you're really, is a 2 by 2 that you're doing. Okay, the only reason I picked up on this is because I've already gone through chapter 10 and done tons of this stuff. Okay, so this is -1 plus 3 is 2. No, plus 0, that's 0, sorry. That's just -1. 0 minus 3 is -3. -9 minus 0 is -9. And that would be your vector. Okay, now we've realized how to get the cross product. I don't care whichever way you want to do it. Okay? I think this is probably the best way, but you need to work up to doing it like this so you don't make any mistakes. Typically, this is what you're used to doing. Alright? What did you find? This vector is perpendicular to the other two vectors. So do you need to put that in your notes or in your reference sheet? That's okay. So the cross product is perpendicular to the two vectors you have. Now we're going to look for the unit vector. Notice we've had polar coordinates and we've had the unit circle. Well, we have unit vectors too. Okay, but it's just a formula. And there's not much to it. So the unit vector is the cross product over the magnitude of the cross product. Cross product over the magnitude of the cross product. Okay, so we're just going to use number 8 as an example. Okay, I can do another one if you want. You can do it so you have a different one in here. We'll do number. They're all nasty. Number 10. Okay, number 10. Here is your vectors. So A's vector is 2, 5, 3, and B is 3, -2, -1. So the first thing you do is you do the cross product. So everybody do the cross product. I'll do it up here the way I want to do it. You do it the way you want to do it. And then look and see if you get the right answer. So part A, find the cross product. Actually, I'll do this with you when you're done. That way you can just kind of see it again. You can walk around and see how you're doing. What are you doing here? Oh, okay. Cool. All right.
You have a marker?
You just use that one.
Put them too close together. I can see.
Good. Yes, right so far, minus the upward diagonal. Yeah. So that's your I position. Go ahead and do that first one. Good check me. Those of you finished, is that correct? You got that? Anybody else get that? No? Obviously, I didn't write down each multiplication.
Oh, I did not.
Yes, alright, so you're getting that. Okay, so you did a mistake. I didn't make a mistake, is that right? So as you can tell, we're starting to do more simple calculations, but there's more of them. When we get to chapter 10, all those matrices and moving rows and columns and determinants and inverses, you're doing all these calculations, there's lots of room for error. So the reason I'm saying that is to try to get you to understand we need to really pay close attention to our simple calculations. Alright, so now that's A. That's the A cross B, the cross product of A and B. Now, how do I find the magnitude? The square root of those entries. So 1 squared plus 11 squared plus -19 squared. And you take the square root of that. Okay? So 121, 122. Somebody do that calculation for me, all of it.
The square root of 483.
Yes, that's correct. I remember the number, I just couldn't pull it out. Okay, so now how do we do this? The cross product is a vector. The magnitude is a number. So you put each entry over the magnitude. So it's 1 over the square root of 483 and 11 over the square root of 483, and negative 19 over the square root of 483. And that gives you a vector. This is the unit vector. Okay? You don't do a lot, you don't do a couple of these problems. Mostly we want to know what the cross product is. That's the basics of what today's lesson is about. Finding the cross product. So the quiz on Wednesday, I'm just going to go through and say, find the cross product of this. Can you give me the unit vector? Okay? That should be very simple. Alright, let's move on. Now let's talk about the length of your cross product. Most of what I'm going to show you next, I'm not going to do an example because you already know how to do it. But we'll see. Go for
I have a question.
it. Yes.
Do you like rationalize it, like times?
Yes.
Or
Rationalize it. It's the same type of thing with improper fractions.
Okay.
Leave them as improper fractions or fractions that aren't rationalized until you're done with the problem,
Okay.
and then go ahead and rationalize them. Just like improper fractions, you wait till the end. And
Pardon the interruption, but our freshmen have returned from the leadership conference, and they should be reporting to their 8th period class in just the next few minutes. Give them a little time to get to their locker, and then they should be coming to class. So
Awesome.
expect those freshmen in class in the next few minutes. Thank you.
Okay. Length of cross product. So the cross product is a vector. We don't know the length of that. Basically, it's the magnitude of the cross product. If you think about what the magnitude is, what are you doing? That's giving you the length of it, of a vector. Okay? Now, here's what you really need. Sometimes you're given the magnitude of A and the magnitude of B, and you're given the angle in between them. If you multiply the magnitudes together and multiply it by the degree, then you're going to get the length of that orthogonal vector. This is how it works. Those two things are the same thing. So this right here is important to know. If I say the magnitude of A, we're going to do, let's do number 14. Magnitude of A is 4, the magnitude of B is 5, and the degree is 30. So you plug that information in and tell me what the length of that cross product was. So given different pieces, you got to be able to work it in different ways. Who wants to work it out? What'd you get? 4 times 5 is 20. The y value at 30 degrees is 1/2. So that's 10. 10 units. Great. Something easy, right? They're not all that, I mean, obviously if you don't get a normal degree, you'd have to use your calculator to get those trig functions, okay? Alright, now, something a little bit different. You might see this on the test. Find a vector that is perpendicular to the plane passing through these 3 points. P is 3, 4, 5. Q is 1, 2, 3. And R is 4, 7, 6. 3 points make a plane, right? Okay. And can't you give me 2 vectors with 3 points? You all find the vector PQ. We're going to do a cross product with the vector P to R. Okay, so you find those vectors. How do we find vectors between 2 points? Section 1. 2 coordinates. How do you find the vector?
Oh, is it the dot
No? I mean, all this stuff starts to go together, so I can understand why you're saying that.
subtraction?
Subtraction. What, look, you gotta understand what a vector is. A vector is just really this horizontal component, which is this distance. Okay? This is x sub 2 minus x sub 1, isn't it? It gives you a direction, it's your slope, really. And then from here to here is your y sub 2 minus y sub 1. So a vector from any 2 points is really their subtractions. Same thing with 3 dimensions. So 1 minus 3 is negative 2, 2 minus 4 is negative 2, and 3 minus 5 is negative 2. You guys do P to R. And then tell me the cross product that you've already learned how to do. Okay? Let's see how you do.
For the, when you do the thing on the right, because when I went, I did because when I did it, because how you got 9 minus negative 2, I did it the other way and it came out. So you always have to go from.
Yes.
Yeah, because I did it the other way and I was like, this one's the same numbers.
So you put B on top.
Yeah, nice.
Did you get opposite signs? Yeah. You also need to remember, if you're taking the square root, plus and minus, those signs could negate. So as you start thinking about it, remember negative vectors go the opposite direction. So what you're setting up is a different direction. If you look at the pictures that go along with this in the book, it's hard to understand what they're doing, but if you look at the pictures, then you'll understand why it is they're going from the A to the B. So, all right, so in this one, 4 minus 3 is 1, 7 minus 4 is 3, and 6 minus 5 is 1. Cross product. I'm just going to set this underneath here. Who got that? I know some of you didn't get to it yet, but then you do the cross product between two because cross product gives you the vector that's perpendicular to 2 vectors in that plane. But you had to come up with the 2 vectors in the plane before you started. Okay? Probably see something like that on the test. Which you're going to get a pre-test on Thursday. You'll see that on the pre-test.
Did you say your test is Friday?
Yes. So the quiz on Thursday or Wednesday, sorry, Wednesday. All right, so let's do something a little simpler. Let's see what I have next here. How about we do the area of a parallelogram? So we got vectors here and here. You can make a parallelogram with it. We find the area of that parallelogram by finding the magnitude of the cross product. How do we find the magnitude? So you're gonna find the cross product and take the square root of the square of the answers, right? I'm not gonna do a problem. I've already shown you how to find the magnitude. All right, the next one, area of a triangle. Yes.
Would it be half of magnitude?
Yeah, half of the area of the parallelogram. Triangles are half of the parallelogram, so 1/2 the magnitude of the cross product. Okay, so just make sure this stuff's on your reference sheet. How about the volume of a parallelepiped? Parallelepiped. Parallelepiped. A parallelepiped is two vectors that make a parallelogram and a orthogonal vector from it that give it a solid shape. So the volume is equal to the dot product of A times the cross product of B and C. You might want to write that dot as the dot product. Remember, dot product is not the same thing as multiplication. Dot product gives you an answer, not a vector. Cross product gives you a vector. So you're going to take that vector and do that first. That gives you the orthogonal vector. And then you take the dot product times A, the vector A. If this is equal to 0, then A, B, and C are coplanar. What's coplanar mean? What? They're in the same plane, meaning there's no depth to it. It's not going to be three-dimensional as far as a box is concerned. That's how you find the parallelepiped. I don't need to show you a dot product. I don't need to show you the cross product. Okay. Page 615. 3 to 33 odds. Oh, you.